So yeah, thank you everybody for being here. We'll go ahead and get started. So we're going to talk about how to build resilient municipal buildings. So not specific to any particular project, but just in general, what's the process? What does that mean? What does it look like? How does it differ from a traditional build process? So we have some great people in the room who have lots of experience doing this, as well as some folks joining us online as part of our panel to share their knowledge, wisdom, and experience with us. We'll just go for it. We'll start with Kim Cullinane, who's the supervisor of new construction energy efficiency with Eversource.
Yes, thank you, and thanks for having me here. I guess I'll look here and up there, right? Okay, thanks for having me here today. And I'm just gonna hopefully go quickly because I think we're gonna each do a few slides and then we really wanna have more of a discussion. But just to kind of set the stage a little bit, if you wanna move to the next slide. So just, we're operating this broader policy context right now. So there's a lot of activity going on at the national level, state level, at the local level in terms of promoting decarbonization in buildings and energy efficiency in buildings. And we at Mass Save kind of sit at that nexus too. And we have, so Eversource is part of Mass Save, I should say that. So Eversource is the utility here in Maynard, but we also are part of the Mass Save umbrella, which exists to provide support for cities and towns and any of our customers who want to save energy and carbon. So we're constantly out there trying to provide technical assistance and support for residents, as well as commercial buildings, as well as municipal buildings in terms of saving energy and carbon. So we sit at kind of the nexus of all of this activity that's going on to drive carbon reduction. And if you want to go to the next slide. So what do people need to do? So, I wanted to kind of say, what are my thoughts on how to be successful? If you're, a city or town, if you're Maynard and you want to build a really highly efficient, low carbon building, what do you need to do? You need to establish your goals. You need to stick to them. So building any new building, whether it's a library or a community center or school, you're going to have a variety of different goals. So establish what those goals are up front. You're going to have program-related goals, use of the building goals, safety goals, particularly with schools, health goals, and you'll hopefully have some energy and carbon reduction goals. So it's really a useful exercise as the owner, as a decision-making body, to go through and kind of figure out what are my goals and then prioritize them. And you do that even before you hire the design team or the owner project manager. Because what you want to do really is put some of that language in your request for services so that you're soliciting teams that can deliver on all of those goals. So we do have examples of RFPs that have gone out for design services and OPM services that have that kind of language embedded. We can help with that. And so that's really important. And you can be broad, like saying, I want a decarbonized building, or I want a net zero ready building or a net zero building. And you can be specific in terms of setting an energy use intensity target. So if you go to the next slide, I'll talk about what that is. So a net zero building, is a building, there's lots of different definitions, but it's a building that generally you produce as much energy, either on-site or off-site, when you buy offsets, as you use or need on-site. So one of the most important things we want to talk about today is, you need to start by lowering that building's energy need down in the very beginning before you think about putting solar on. Solar's kind of a nice to have afterwards, but everything you do throughout the design really needs to focus on lowering that energy use intensity, which is a measure of the total building's overall annual energy use divided by square footage. And then you'll actually save money in terms of what HVAC system you're putting in the building, in terms of its capacity, in terms of how much solar you need to put on the building, because the energy needs are going to be squeezed out. And the next slide kind of shows this graphically. So you've got the left side of the balance here, where you've got your kind of heavy building. The consumption is on the left side of the balance, representing EY, energy use intensity. It's heavy, right? So that's a kind of a standard building. You're not going to offset that with solar. What you really need to do is trim down that usage, that expected usage on the left side. That's the most important thing to do first. And then if you want to put the solar on, you can, and you can try to offset that usage. So we talk about energy use intensity all the time. It's setting targets, and the value of that is it really drives the design team towards a specific, and it keeps everybody focused too. So the design team, but also the ownership team too. They have a clear and unambiguous energy carbon target that they're focusing on. They can make decisions against that target. It also requires the design team to be looking at it periodically in iterations throughout design. So they have to be doing an energy model, and they have to be doing runs at different iterations and checking to see, are we reaching that target? Are we off? If we're off, why are we off? What can we do to take corrective action? And very importantly, it's a target that you can measure after the building is occupied. We set the target, we design toward it, but then you can actually look and see, did we hit it in operation? And that's what really we should all be focusing on, is the operation. It's not really about the design and the prediction, it's about the performance at the end of the day. Are we really saving the energy and carbon? So I'm here as Eversource, representing Eversource, but not Save. And so we do have significant incentives that we offer to offset the costs of going to very low carbon, very low energy use. The heat pump incentives are available for any project that's a new construction or a complete gut renovation, all the way up to $4,500 a ton for ground source heat pumps. So we really are focusing on heat pumps as well as low energy use intensity, as I mentioned. We set EUI targets with our customers. This is just here, not for you to memorize, but just to say, regardless of whatever building tech you might be doing, we can help you set a good energy use intensity target and help you work towards it. That's really the value of what MassSave brings. This is just an example to kind of show you the size of the incentives that we offer. It's actually a real building. This is hasn't formally engaged in the program, but we expect it to. It's a school building, 172,000 square feet. They are planning ground source heat pumps, so $340 a ton. You can see, I won't go into all the details of how our incentives work right now, but you're getting up to over $2 million from Eversource for this project. And then I have a note here that says, you can layer on the IRA tax credits on top of that. So those are two completely distinct things. Our program offering the MassSave incentives, and then any additional support for tax credits. And then just here, last point that I'll make here is that we're seeing a lot of public buildings doing this, going forward with low carbon strategy, going forward with energy use strategy, because public buildings are owned and operated for 50 years. So they're really a good investment for doing this sort of thing. And we're seeing a lot of activity across the state, definitely in the K-12 school front. We're seeing more and more public safety buildings, libraries, community centers coming through with these net zero and very low energy use aspirations. So a lot of public projects. Public projects are the biggest sector, and then universities are the second biggest sector for the state. So I'll leave it at that. To Chris.
Yeah, so hi everybody, thanks for coming out and talking with us today. My name is Chris Schaffner. I'm the CEO and founder of a company called Green Engineer. We're based in Concord. We do green building consulting and energy work, and I'm also here kind of as a hat of a citizen advocate. I used to live in Acton, and Kate and I worked together on the Acton when we were the Green Advisory Board, but an energy committee working at how to set goals and targets for town. We do a lot of work with public projects, also a lot of work with private projects. So I'll talk a little bit about some of the ways to get to resilient building. Resilient is a big word. Kind of boil that down here to looking at resilience in terms of energy. There's a lot of other aspects that we're not covering. So my slides that think about this idea of net zero first is a potential thing that people are trying to get to. And Kim talked a little bit about what that might mean. There's a general approach to this, and the idea is that we go through multiple steps. The first is we want to drive the loads down as low as possible, and only then can we make up the rest with renewables. But if we just start with renewables, that's the wrong place to do that. So there's some specific things that we look at with net zero. Go to the next slide. There's a basic strategy that we like to follow for energy efficiency. And the first is reducing demand. So it's all the loads in the buildings. That means a good building envelope, low lighting power density, right sizing for other process and equipment loads, getting the ventilation right, doing all we can to reduce loads. The thing that's great about that is that you spend money on things like the building envelope, it makes all the rest of the system smaller and cheaper to build and own and operate. So there's a potential of an offset. We can think about investing in insulation instead of a bigger heating system, for example. The next thing we want to think about is what kind of energy is already on site that we can use. So obvious things like natural light, we can turn off the lights and do that. But less obvious things like we can capture the energy from exhausts to preheat the building, so harvesting said energy. Then we look at the systems and the efficiency, try to make those as efficient as possible. First, we want to make them as small as possible. And then it's really important beyond that, as Kim touched on, to look at operations. And one of the things we found in our work when we follow up on projects to see how they've done compared to how they're predicted, is one of the big issues, especially on public projects, is getting the appropriate level of complexity in the systems, right? We can't have a system that has got too much complexity for the people who operate the building. And different types of buildings are going to have different needs. You know, a large high school might be very different from a branch library, for example. So we need to think about who is going to be managing these buildings once they're in operation, involving them in the process during design, and making sure that everybody is clear on the design intent of that. And so that operations and maintenance part is super important. Commissioning to make sure the system works embedded. And then we think about renewables if we want to get to net zero. So some common themes we've seen for the next slide for these successful energy projects. Establishing energy targets early, like Kim said, focusing on reducing loads. And then we look at different kinds of mechanical systems, especially heat pumps and in schools, things like displacement ventilation or chilled beams. We use modeling and other analysis tools to test alternatives required in Massachusetts for public projects to do life cycle costing. That's actually part of the state regulations around these projects. So we do that. And then we think about, can we eliminate fossil fuels and can we bring in fuels? We do all these other things first. So just a little more highlight on that typical process we might go through on the next slide for setting. Well, so first of all, we want this process to be integrative. And what does that mean? Well, in my mind, it's an idea of it being iterative, right? So we come together, we look at ideas, we analyze them, we come back together. We're narrowing in on a solution, but it's not, here's a design and now we'll go run a model and figure out how much energy it's going to use and we're done. It's a process where we come back and we look at different options and we narrow in on things. So I want to start early, casting a wide net and narrowing in both qualitatively and quantitatively. So that's the basic process that we're thinking about, getting the right people engaged at the right times. And then we set goals, and maybe the goals are set on the next slide even before the rest of this process starts. So, you know, EUI target setting, Kim mentioned what an EUI is. So it's really important to look at this in context. We like to look at not only the targets that folks like Bassam has set, but what are your other buildings in town doing? What are similar buildings? What are projects that have recently completed doing? What are you capable of doing? And setting some goals in that area. Trying to set something as low as possible. And then we come to this question of, do we want to electrify, do we want to decarbonize? Next slide will help us with that. Hit the button one more time. So what we find is the grid has been getting cleaner and cleaner. And, you know, if you go read the comment section in your typical local newspaper, somebody will comment about everybody's got an EV and they're all powered by coal. Well, that maybe was true 20 years ago, but that's not true anymore. Our electricity in New England is pretty clean and it's getting cleaner. The state has set very ambitious goals to be net zero by 2050. So, you know, at the local level, we kind of got to say, okay, that's going to happen and we're going to work along with that. And so that really makes moving towards electrification very important. It's going to allow us to reduce our carbon emissions over time just because the grid is going to get cleaner. If I've got a building that's burning gas, it's always going to release that amount of carbon. It's the chemistry of burning gas, and it's not going to change. But if I've got a building that runs on electricity, it's getting cleaner over time. But even right now, they're cleaner. And the next slide shows some analysis that we did on a recent campus master plan. This is for a private school in the greater Boston area. And they have a steam plant where they make steam to heat a bunch of buildings on campus. And so the question was, our next building, if we're thinking about carbon, what do we want to do? And so we looked at generically 5 different options. Use their existing plant steam or put in a new gas-fired high-efficiency boiler in their building. And what we found was by switching to heat pumps, either air source heat pumps, the inexpensive ones, or ground source heat pumps, the ones that cost a little bit more, we're cutting the carbon emissions from heating by more than 50%. The one thing we don't want to do if we're electrifying is put in electric resistance. That's still the worst way to go for everything.
Baseboard.
Baseboard, yeah. I mean, it's basically you using the equivalent of a toaster to heat your building. That's a bad idea. That's going to be the most expensive and the most carbon, even now. But our grid is pretty clean. So we have low numbers when we look at these other sentences. And now we start to think about, okay, we've got this low energy building. Do we want to try to get to net zero? So there are actually a bunch of different ways that we classify buildings as net zero. So I think most people assume that their net zero building is going to be this class A net zero. There's solar on the roof that equals the amount of energy in the building, or maybe class B. We work with the state on Walton Pond Visitor Center. That's a net zero building. It's actually a net positive once you include the 100 kW solar array on the parking lot next to the tiny little building. Not every project can be the visitor center at a state park. They're bigger buildings with more loads. And so most of the net zero projects out there, the municipal ones, the schools, not all of them, but many of them are class C, meaning they've got off-site renewables. We did this with the town of East Hampton, for example. They built a new public library. They also have a solar array on their landfill. So together, that makes the public library net zero. And they've since then actually put solar on the building itself, and it's close to class A net zero. It's not quite there yet. But you know, as you think about this from a town, you should be putting renewables in the place that makes the most sense for the town, not necessarily right on the building. Now, Mark's going to jump in and tell me there are some issues around the tariffs and some of the other things that are there for that. Yeah, that's true, but you know, be creative here. And then some, you know, folks that are net zero are actually still just buying RECs or green power or something like that to do that. And that counts as net zero too. So when you read about what other towns are doing, look a little closer and make sure you understand what they're actually doing, because not many of them are actually that class A net zero. And then finally, when we think about renewables, one of the things that we see on the last slide here is that many public projects especially get a little creative with how they do renewables. So we build buildings that might be net zero ready, so we can bring in renewables later. We often see, like in Lexington, Mark might talk about the school we work with them there, where they actually have a separate vendor brought in the renewables after the building was built, different contract, to do PPAs, third party, think about community. And then with the IRA funding now, there are new incentives that haven't been there in the past for people who aren't tax-paying entities. That's always been one of the things that have been driven PPAs in the past, is that the private company can get the tax credit, the town can't. So that seems to be changing with the new IRA. So we would encourage you to think about renewables as an important part of the project, but not the key element. The key element is really low energy building, hopefully electrifying as much as possible, and then planning for renewables either now or in the future. That's my last. So thanks for letting me chat for a minute.
So next we'll have Larry Lazard, who's joining us online. He's the Director of Achieve Renewables and President of the Geothermal Professional Association.
Thank you. It's a pleasure to be here, honored to be invited. And what I'm going to talk about ground source heat pumps and the application of those to municipal buildings in general, but also for zero net energy targets. Next slide. So first, a brief introduction to ground source heat pumps and how they work. Next. Very simply, we put a heat exchanger in the ground. The ground heat exchanger is typically, at the sites we work at, a vertical configuration put in with the drilling rig, and the number of borings and how deep they go is a function of the energy demands of the building. So as has previously been pointed out, reducing energy demands reduces the amount of ground heat exchanger we have to install. The ground heat exchanger should be viewed as the fuel for the buildings. It's where we recover the heat that's used in the winter for heating, and where we place the heat in the summer when we're doing air conditioning. Next slide. This is sort of a busy slide, but I'll try to hit the highlights, summarizing topics for ground source heat pumps. Not all of these topics will I be going into in any kind of detail today, but they could be the subject of some future discussions. So ground source heat pumps are highly efficient. They have more than double the efficiency of air source heat pumps on an actual annual basis in our climate. That is sometimes hard to discern because the rating system that's used for ground source heat pump focuses on worst case conditions, and air source heat pump ratings are somewhat more optimistic. But nonetheless, in an actual operational scenario, ground source uses quite a bit less electricity to achieve the same amount of heating and cooling. Ground source heat pumps are robust and they're scalable. The number of ground source heat pumps you install and their capacity can be varied, as can the size of the ground heat exchanger. So essentially any size building can be addressed with ground source heat pumps. However, the most efficient systems are those where the loads for the building have been reduced to the greatest degree practical. And ground source heat pumps are a complete heating and cooling solution with no requirement for a fossil fuel backup. Of interest to the electric utilities, ground source heat pumps reduce peak demand. Peak demand is the demand on the electric grid during extreme conditions. For example, a very hot period in the summertime would have a high peak electricity use. Because ground source heat pumps use less electricity, and because their efficiency doesn't change based on the outside air temperature, they will reduce peak demand compared to air source by half or sometimes more than half, depending on the specific location in the state you're in the climate. Ground source heat pumps also have a very long service life, lasting about twice as long as competing technologies. And the main reason for that is that the equipment is all inside. There's no outside heat exchanger that's subject to the ravages of salts near the coast or other things that can corrode that external heat exchanger. The underground components have an extremely long life, typically estimated to exceed 100 years. So when ground source heat pump systems need to be updated, it's the indoor equipment that's updated. The underground heat exchanger would remain the same, and unless the building were somehow substantially being increased in size. Ground source heat pumps are also budget friendly for municipal facilities because of the low operating cost and lower maintenance cost compared to other alternatives. Ancillary benefits are that they're very quiet, there's no outside equipment. Eliminating fossil fuels also eliminates carbon monoxide risk in the building. And ground source heat pump systems, typically being ducted systems, have the potential for addition of high efficiency air filtration, which can be useful in relative to allergens or pathogens. Next slide, please. As Chris mentioned, ground source heat pump installations are more expensive than other alternatives, including air source heat pump systems, but that's the pre-incentive cost. There are substantial financial incentives for ground source heat pumps that make the post-incentive ground source heat pump installation costs very competitive with other alternatives. And as Kim had mentioned, MassSave provides $4,500 per ton of heating capacity, which is 25% to a third of the installation cost. The federal government has a tax credit program that's easy enough for for-profit institutions to take advantage of on their taxes, but there are allowances for nonprofits and municipalities to receive a distribution from the Treasury in lieu of the tax credit. That law was passed last year, and I believe we're still waiting for final regulatory implementation by the Treasury. But there will be a pathway for municipal projects to get at least some benefit from the tax credit. The renewable energy tax credit, there's a base tax credit of 6%, and then different technologies have multipliers that apply to that. The ground source multiplier is the highest at 5. So the base ground source heat pump tax credit is 30% of project cost. If US made equipment is used, you can gain an additional bonus 10% to get you to a 40% tax credit. If systems are above 286 tons, there's a additional requirement for prevailing wage or union labor. But on a school project, that would probably be the case anyway. Next slide. So just a couple of points to remember before closing. Ground source heat pumps have the lowest operating cost of the available alternatives and lowest electrical use. They can provide, or they typically do, provide heating and cooling during installation, and can also provide domestic hot water. They have a long service life that's double that of other alternatives. And the post-incentive installation cost is attractive compared to other alternatives. And a quick plug for our organization, members of the New England Geothermal Professional Association that you can find at negpa.org are technical experts that can design, install, and service municipal ground source heat pump installations. And our members, including my company, work closely with engineering firms like Chris's and Mass Save for these projects. And I believe that's the last slide. Thank you.
Thank you, Larry. So next we have Mark Sandeen, who's a select board member in Lexington, who's also joining us online.
Well, thank you. Thank you for inviting me. I'd just like to tell you a little bit about Lexington's experience designing 2 net zero schools. And it touches on many of the points already made earlier by the previous speakers. And I've had the pleasure of working with Chris on a bunch of different projects now. So one of the things that Kim talked about was setting goals and sticking to them. And one of the things I'd like to talk about is the importance of doing what we call establishing the town's integrated building design policy. So in Lexington, we asked ourselves, is it going to be possible to design healthy? So we haven't really talked about that very much today, but healthy buildings that are resilient and all electric, that have the highest standards for indoor air quality and energy efficiency, that maybe generate more energy on site than it uses, and to do that at a total life cycle cost that's lower than a traditional design. And what we found out is that the answer is yes. And Hastings School is, if you go to the next slide, is a design picture of Hastings School at the design stages about 6 years ago. Is a 110,000 square foot building for 645 students, but it's occupied and it's operating and fully occupied today. And the solar energy system and energy storage system are expected to be interconnected in a few weeks. The foundational critical success factors in this decision-making process is changing our financial focus from looking at things in terms of upfront costs and payback times to looking at them from a cash flow model based on how we actually pay for our buildings. So let me ask you a question. How many of the folks listening today pay for their buildings with cash up front? I know in Lexington, we finance our buildings with a 30-year bond. And so the building's total cost is actually our cash flow. And that's a combination of the operating and maintenance costs for the building plus the debt service on the bond. So our life cycle cost analysis, we try to focus on whether the lower operating and maintenance costs of, say, a ground source heat pump, as we were just talking about, or energy efficiency investments, or renewable investments will actually offset the increased debt service of the design changes that we've made in order to accomplish a net zero building. And our target is always to be cash flow positive on the very first day the students move in. So how'd this journey go? When we first asked ourselves, this is about a decade ago, is it possible to design a net zero school in Massachusetts? There were no net zero schools in Massachusetts at the time, and the conventional wisdom was that it would probably be impossible to design a 3-story building with a gymnasium and a cafeteria in Massachusetts' cold climate to net zero standards. And so we said, could we start with the building's overall energy efficiency? And we set a target of 30% lower than conventional code designs. And surprisingly, Chris and his team came back with a cost-effective design that reduced our energy. It was surprising for us, maybe not for Chris, but it was surprising for us that reduced our energy use by 50% compared to code, while still achieving our highest standards for indoor air quality. And conventional designs would have filled that whole roof with HVAC equipment. If you're putting a boiler in and air conditioning, you would have chillers on the roof. If you're putting air source heat pumps in, you'd have the air source heat pumps on the roof. And that would not have provided a lot of room on the roof for solar. But ground source heat pumps could free up the roof for solar, but they would dramatically increase the cost of the project. So even with solar covering the roof, there wouldn't have been enough power to get to net zero. So we asked, to Chris's point, what about our parking lots? Could we put enough solar canopies up in our parking lots to make the difference? And the answer came back, yes. The solar canopies now are producing roughly about 2/3 of the building's energy uses, and the rooftop solar covers the rest. So let's look at the economics of this. A lot of people think that if you put enough solar on site to cover all of your electricity costs, you're going to be able to reduce your electricity bill to zero. But that doesn't work out that way, because in Lexington, about 45% of our electricity charges come from demand charges. And solar power doesn't do a whole lot to address that. So what we've done is we've done solar and storage, and I don't want to spend a lot of time talking about that today, but if you have questions about that, I'd be happy to talk with you. What we found is that the solar is sort of like a booster rocket in terms of making the economics of this work out. So the other kind of success factor in this process is using what we call a scenario-based model in terms of looking at the key assumptions for this project from a low, medium, and high estimates, whether that's how big your ground source heat pump needs to be, how many feet of pipe you need to put in the ground, to what are the low, medium, and high guesstimates of what natural gas prices and electricity prices are going to be over the next few years. What are your interest rates going to be? What's your cost of money? Those kinds of things. And of course, as Kim has talked about, what kinds of potential incentives are available in order to pull this all off. And so what we found is, if we go, go to the next slide. What we found is that by modeling things in a low, medium, and high, and comparing that to the debt service, we said there's 3 different sizes of ground source heat pumps we think we might be needing. And there's 3 interest rates at which we think we might have to finance that additional incremental cost for the ground source heat pumps. And then we compared, if we're powering those ground source heat pumps with solar and storage, what are the potential revenues from that? And what we found, it was really interesting, is that if we took the worst possible case and said that the ground source heat pump was as big as it could possibly be, and the interest rates were as high as they could possibly be, and somehow or other our solar and storage revenues were as low as they could possibly be, we still came out net flow positive, cash flow positive. So it sort of made it be a no-brainer from the financial perspective that we should be going forward with. And I love Chris's second to last slide, the integrative design process. So we talked a lot about that. Basically, all of these things work together so that If we had only looked at envelope on its own, maybe that might not have made the cut in a sort of standard ROI basis. And if we'd only looked at ground source heat pumps on their own, that might not have made the cut on an ROI basis. And if we'd only looked at solar on its own, that might not have made the cut on a overall basis. But when you combine all of them together in an integrated process, they all pay back. And so we have substantial savings for Lexington. So this is a highly repeatable process. You can go to the next slide. And that's what Hastings School looks like today. We have now done another net zero preschool building, the Lexington Children's Place. It's about a 20,000 square foot building with 72 students. We've approved an all-electric HVAC design for our fire station, our police station, our visitor center. And we are now in the process of starting work on our high school. We have now, just in the last month or two, received MSBA approval to build something on the order of a 450,000 square foot high school. So those are the outcomes we desire to have high quality health first is our number one goal. And then to reduce our total life cycle cost while eliminating emissions. So thank you.
Thank you. And last but not least, of course, Kate Crosby is the energy manager of the Acton Bottsboro Regional School District.
Good. Hi, everyone. Good afternoon. I just came a short hop down from Acton and want to talk with you about, partly inspired by Chris's work and coaching from Eversource and what has happened in Lexington and other places around the country. When Acton Bottsboro was going to be putting up a new school building, we started taking a very close look at this approach. And last August, we opened a new school building, which you're welcome to come and see. It's just a few minutes from here. And we opened it on time and on budget, which was very exciting in the middle of COVID, especially. And I want to, it is a large building. It has 2 elementary schools and a preschool inside of it, so 2.5 programs. It has we've set a goal. You've heard this. Much of what I'm going to say is going to resonate with what you've heard from other speakers. We had tremendous support from Eversource early in the process. They were really key for us in helping us believe that we could take a close look at this and move forward. And we set a target with their support very early of 28 as an EUI target. The building that we put up is modeling at 23.6, so lower than the EUI target that we set. And as you've heard from other people, we ensured that the building envelope was very tight and very well insulated. That's actually the foundational piece, so that you're not wasting money on utility bills, which nobody wants to do. We then, the building committee selected a geothermal system based on an engineering analysis looking at a life cycle cost analysis over 50 years. The geothermal and the, would you go 2 slides forward? Okay. This was the, yeah, there you go. This is, there are 2 links on the bottom of this, which will take you to the engineering study that was done for this building. And you can maybe not read what's there. There are 4 scenarios that were looked at. Number 2 is a high efficiency gas system. And number 4 was the geothermal system that was chosen. And the utility bills for these were projected year after year after year to be identical. Because the geothermal system has a lower EUI, is more efficient. It actually, although all electric, it has the same, was projected to have by the engineers have the same utility pricing as the gas-fired building, because gas-fired never can get as efficient as geothermal. So that was a real key. The price of the geothermal, the capital cost was higher up front, but pays down over time because you have lower replacement costs for equipment and lower maintenance costs. So if we were looking at a 50-year life cycle cost analysis, it was a wash by the time we got to, all the way up to the end of the spreadsheet. So as public owners, 50 owner-operators of a public building that's going to be in service for 50 years, it was an easy choice for the building committee to, in the end, although there was a lot of learning that happened along the way. And if you'll back up one, that'd be great. So this is on the left, you can't quite see because that little icon, but the conventional gas-fired building has an EUI of 40, and Boardwalk has an EUI, boardwalk building that we've just occupied has a projected EUI of 23.6. And so that's through greater efficiency. The red arrows at the bottom are pointing to heating, cooling, interior lighting. All of those are far more efficient inside this building. And that's helped by this very efficient load as well. I want to remember to say that I think I've actually said a great deal. The town meeting approved the funding for this building in December of 2019. Would you go back to the first slide, please? It was an MSBA project. It was built on a conventional budget, nothing fancy about how we paid for this. These choices were made before the mass save incentives came out, the very handsome incentives that you've been hearing about today, $4,500 a ton for geothermal, was made before the federal IRA legislation. So both of those are now in place and will make the geothermal pencil out considerably better than what we were looking. So it's really important for mayor to take a look at these choices. The building is all electric. There's a diesel generator on the back. If the grid goes down, and we are putting enough solar on the roof and on the parking lot to power the building. So that's a sort of a secondary choice after you achieve a very tight building and make your decision about it, right? So we are going to, between the solar array and the battery storage, we're going to cut our demand charges. We're going to be getting cheap electricity, and we'll come out way ahead of the gas-fired building in the end, because we'll be making our power on site. But even if you're doing the conventional engineering analysis, looking at conventional power, the utility cost for this building would be the same as the gas-fired building that was the other choice. And I just want to, it's just an exciting world that's opening up, and lots of things to learn and take a look at when you're considering putting it on. Thank you.
All right. Some questions.
Thank you all so much. So I think Kate was monitoring questions, so I will go ahead and ask the first one, unless Ken's got one ready to go.
You go ahead.
So I think resilient was a word that kind of got thrown around a whole bunch. We've kind of covered like what net zero is, but maybe sort of unpack a little bit what the connection is between resilience and net zero. What are we going to be resilient to by looking at net zero, by being really energy efficient, and certainly to energy costs by just not using as much as we might otherwise. Are there other benefits to being resilient, other reasons that we should think about resiliency in terms of building buildings?
I'll take the first crack. When you say other benefits, I want to underscore what Mark talked about, which is that a really significant benefit for us is that the indoor air quality in this building is terrific. And so that improves cognition, it improves it reduces absenteeism, improves staff retention. It's a very quiet building, and the air quality is really high, and that's all really powerful for operating school. Resilience is another layer, right? So if you're making your cake, that's perhaps the frosting on the cake, and we were aiming for resilience. We couldn't quite put in the last piece that we needed to put in. We hope to someday, so that the solar panels can be talking to the battery, can be talking to the building if the grid is down for an extended period. So almost got there, not quite time. The potential, the infrastructure is there if we can tie it together correctly.
So when people talk about resilience, they often first talk about just preparing against climate change, and it goes to things like flooding and short-term power outages, things like that. But another way to think about resilience is future-proofing your building. So I think one of the things to think about, if you're looking at a building that's got a 50-year or more lifespan, what is it going to be like to be a consumer of fossil fuels in 2050 when everybody wants them to be gone? Are you going to have to go back and retrofit these buildings at some future time because of various penalties or other things that might be in play? We're seeing that already in cities like Boston and New York that are putting in place rules around existing buildings' energy consumption, and building owners in Boston are confronted with the idea that they're going to pay to the city $200+ a ton of carbon from any fossil fuel emissions they're going to have at some date in the future. So that's happening in Boston and New York right now. You can easily imagine something like that happening across the state or across the country at some future date. And you just don't want to be the last folks still burning fossil fuels when everybody else has gotten rid of them, I think. So that's one aspect of resilience.
You want the carrots that are available now, not the sticks that are.
Yeah, exactly.
Yeah, I'll just add on the resilience tie-ins net zero too. We talked about a lot about the load reduction analysis and getting the energy demand of the building down as low as possible. That usually means really a lot of work goes into the envelope. So it's a really robust building enclosure. And when you do that, you do it right, you know, you're hedging yourself against the short-term power outages. So the building tends to hold its temperature. And a lot of times, you know, public buildings are used as emergency shelters. And so there's a resilience piece there too.
And then when you go to the geothermal specifically, those really, you know, one of the issues with the air source heat pumps that people get concerned about is the very low temperatures outside. And will the heat pump still produce? Well, so geothermal, you don't have that issue at all.
And actually, we had a power outage. I think the date, I think I can't remember, in December, and the building just, we were worried about it over the weekend. It just was a cold snap and it just cruised. It was amazing. It was really great. So
It basically heats itself.
So
yes.
let me add one thing. So Kate mentioned this study about cognitive performance. And so one of the things that you think about in terms of resilience is how fast you can respond in a crisis. And the study that Kate is quoting from about cognitive performance in buildings with good ventilation and air quality comes to the conclusion that you have 4 times better response in a crisis. People respond 4 times better in a crisis when they have good indoor air quality and ventilation, when they're breathing fresh air. So there's another aspect of resilience.
I have some questions over here.
Go for it.
And comments, but maybe we can jump back and forth.
Yeah, sounds good.
Okay, so this is for the panel. Can you talk about timing for reimbursements relative to 1, mass save, 2, IRA tax incentives, and 3, the MSBA reimbursement?
I can start. So I'll speak to the mass save incentives first. So we pre-approve our incentives. So we sent out a formal offer letter to our customer, which would be the town mayor in this case, at the end of design. And then we make our first and largest payment at the end of construction. So once construction is complete, we ask for documentation. So we're going to be looking for, you know, final submittals to document that certain equipment is in the building, that it was built as designed. We'll do a walkthrough, and then we cut our check at the end of construction. There is in the program that I didn't go through the details of the program today, but we have in our most robust offer, we have a post-occupancy performance component to what we offer these days too, because we really want to tie the predicted energy use to how it's actually performing in the field. And so that would be a second check that would come, you know, a year, 2 years and a half after the building's up and running, if the building actually meets the target AUI that was set out for it. But the vast majority of the incentives would be paid at the end of construction. So that's mass save, and I'll just touch on, you mentioned the others can speak to MSBA better than I can, but on the IRA piece, that, you know, you have the project has to be in service. So that would be also at the end of construction, then you would need to file your tax, you know, your tax returns, and you can't do that. This new IRA, you know, the legislation that was signed last year allows for direct pay to even non-tax-paying entities, including municipalities and other nonprofits. So you would be able to file for that. Now, there's still a lot of ambiguity and uncertainty in terms of exactly what's covered by those tax credits. And so we're all waiting with bated breath for the IRS to release more guidance on that. But once we have that information, I think that will funnel right into this process.
Right, the ambiguity is because Treasury has not yet finished issuing the guidelines.
Exactly.
So it's hard to speak to at this point.
Yeah. And so as far as the MSBA, whether you're doing it this way or as a conventional building, if it's MSBA funded, it's the same process and the same payment schedule. And the way that that typically works is that there is some amount held until the project is completely closed out. So after the commissioning process is finished, MSBA requires projects to be LEED certified. So they typically want to wait to see that you've actually achieved the certification before they let you check. Or chips, you could be doing chips instead of LEED, absolutely. But some sort of green building certification. And so that can be the holdup for the final payment there. But that's, you know, so you're looking at 6 months to a year after construction typically is the time frame for these sorts of things. CHIPS is the Collaborative for High Performance Schools. So it's a green building rating system. It's very similar to LEED. Actually, it was before LEED, because LEED once upon a time didn't have a version for schools. So CHIPS was the only game in town, and there was a Massachusetts CHIPS. Now there's a New England CHIPS. I see it's just different. It's different. Yeah, they're very similar. And when we're working with the school, one of the things we do up front is we go through which one you want to do. These days we see a few more kind of going towards LEED, and maybe that's our preference because we do LEED on all those sorts of other buildings. But there are many CHIPS projects out there as well, and they have different pros and cons to them.
One of the things that our project is CHIPS, and MSBA allows you to choose either.
One of the things that CHIPS does is it really engages the district in the operational side much more than LEED does. So we find some projects that's a plus, and some projects they'd rather not engage the district. They want to just get it built. I'm not sure why that would be, but that becomes part of the preference there. Very similar.
Can I ask a question?
Go for it.
Very good. Hi, I'm Jeff Swanberg. I'm in the Maynard Select Board. I'm sorry I wasn't able to join you in person today. So one thing I noticed when I talked to people who are professionals in the building, the architectural industry, et cetera, is that they're often overwhelmed by the speed at which these technologies have arrived and at which they're being able to incorporate these into design. So I know we talked a bit about this on the geothermal section, but are there other resources for, say, our architects or even citizens in town who are, have been doing buildings and designs for a number of years, but haven't been asked to incorporate some of these clean technologies before? And they know that they will be building, future buildings, but for the ones that are in front of them today, they're uncertain on how to really make sure they're designing and incorporating all these elements correctly in a way that's going to be sustainable over, a multi-decade lifespan of a building.
So I'm going to take a first cut at that. So as part of the Mass Save program offering for any new buildings that are coming in, I think that's where you're principally talking about new projects that might be coming down the line. But one of the things that we do is we'll bring in a third-party expert. So we'll bring in firms like Chris's firm, the Green Engineer, or other firms like Firm Tomasetti, which was used in Active Boxborough, or Slipstream, which was used in Active Boxborough. So these firms have a lot of experience doing this type of work over a broad number of projects. And so they're very expert in doing things like looking at load reduction analysis and helping optimize that, helping you bring those loads down first and foremost. And then they've seen a lot of different iterations and combinations of HVAC system types, so they can comment on that for you and maybe help you optimize there. They've done life cycle cost analyses, or they can review yours and comment there. So we do bring in that extra level of support for the reasons that you just articulated, that this is new for a lot of people, and not every design firm's got this nailed.
Yeah, but it has been changing very quickly, and I think that's been, for old guys like me, it's been a little tough sometimes to catch up, because 20 years ago gas was the bridge fuel, and a clean condensing boiler was really the way to go, and air source heat pumps were great, but they wouldn't really work below 20 degrees outside. And that was kind of the mythology that's still there. And these, ideas of building the passive house level on the building envelope seem daunting and kind of over the top. And the speed of change has really been very rapid in the last few years, especially the push for electrification. Suddenly everyone is there, and we've seen this not just on projects, but also public advocacy. We've had projects. We worked on a project in Worcester that they went through the original design phases, and they decided they wanted high efficiency gas boilers because that's what they'd had on previous projects that had been very successful in low energy. And come to find out in the middle of design development that local groups like Mothers Out Front were at the meeting and talking to the mayor of Worcester, and suddenly they're redesigning these buildings midway because they want to try to eliminate or at least reduce the fossil fuel use there. So, I think that's kind of one of the messages I give to architects who are a little unsure, is like, do you really want to do redesign midway through this? Why don't you look at what people are actually doing? So resources that are there, for me, what I look to is a lot of the local resources and two very good ones we have in Greater Boston. The BSA, Boston Society of Architects, does a lot of outreach to the architecture community and the general building community, and a lot of education around carbon, and not just operational carbon, but also a huge effort on embodied carbon, which is something we haven't talked about here at all. And also we have a local nonprofit called Built Environment Plus, which is among other things, a local chapter of the U.S. Green Building Council, but it does so much more. They have a lot of training, and again, architecture and design firms can actually do training paid for through the state workforce development grants. So you get a lot of education on that for free. There are other organizations. Another one that I have to mention would be NESI, the Northeast Sustainable Energy Association, who has been a leader in green buildings and energy efficiency for probably 40 years now. They're based in Greenfield, and they are a tremendous local resource with a lot of information and a lot of people who have done the net zero buildings as part of that. So those are all good places to go talk to people. And, you know, in Mass Save, certainly we call Kim very often and say, where has somebody done this? And they know, because they've been involved with these projects. So going and talking to, you know, Kate in Acton, or people in Mark in Lexington, or in Ashland, or in Worcester, or wherever people are building similar buildings, and seeing what's being done and what works is a really good way to bring yourself up on the learning curve. And, you know, I learned a lot on all these things. Mark was talking about that life cycle costing he did. I have to admit that I did a life cycle costing on that project first, and it showed that the ground source heat pumps cost more upfront, and we're going to have a higher operating cost, and so we shouldn't do it. Is I think how it's actually quoted in the Lexington Minuteman. Is that the paper? And
don't really have a paper anymore.
Well, in fact, you can search for it online, and you find me speaking against that idea. But Mark did is he did this amazing financial analysis where he did bring everything together. And once you look at it in that way, in an integrated way, like, oh, okay, this is better than this. You've got to look at it as a whole picture. That was really important, and I learned how to do that from working with Mark. So you know, we're all figuring this out as we go.
So thank you, Chris. Let me just sort of build on something you said, though, and Kim. At the beginning, she said you need to set your goals and stick to them. And one of the things we did in our integrated building design policy is we said, these are our goals, and we are going to select design teams that are capable of meeting those goals. So we said in our RFPs, you need to justify that you can build to these goals as part of our selection criteria.
And I'll mention in terms of resources that NESI runs a very fine pro tour series each year. And the school building in Acton is actually their first pro tour this year. So April 21st, NESI is running a pro tour at the building. So anybody who would like to sign up with NESI, you know, it's oriented towards professional folks, engineers and architects, but anybody can sign up and come have a tour that day. And we'll you know, there are other opportunities to come see the building as well. And if anybody from you know, a Maynard committee would like to come, we'll be happy to host.
Can I ask a follow-up question on that? Kate, I spoke with you. My name is Julie. Hi. And I had my talking. Yeah. One of the questions that we tend to face when we're looking at this cost estimation is that switch in viewing systems from a 20-year or a 30-year life cycle to really cost comparing geothermal systems, which have as was mentioned earlier, a much longer scale for their equipment replacement cycles. So I guess, Kate, one of the things that when we had talked previously, you mentioned that initially in the cost estimation, you were looking at a 30-year life cycle. And when you took it out to a 50-year life cycle and really cost compared to that level, the numbers switched. So I was just wondering if you guys could speak a little bit to the cost analysis and just time scale that's appropriate specifically for comparing, you know, reasonably comparing geothermal system.
Sure. I mean, the work that Mark has done in Lexington with stacking costs and understanding some of the hidden benefits is wonderful. We actually didn't do anything as fancy as that. The engineers did a 20-year life cycle cost analysis looking at maintenance costs, fuel costs, and equipment replacement costs, just a straight up life cycle cost analysis. And we asked them to run it at 50 years, and at 50 years, it had essentially paid its person. So, you know, it was, they were just slightly off each other. So that's on, you know, so what Mark is pointing to is additional factors to look at in terms of costing, but a 20-year life cycle cost analysis, which is what we initially had, doesn't really show you what a geothermal system.
So in Lexington, we had long debates about how long the equipment would last, right? So nobody can agree, right? So is it 50 years for ground source heat pumps, or is it longer? Is an air source heat pump going to last 15 years, or should we use ASHRAE numbers? And so this is sort of the benefit of this scenario-based analysis. You can get to a consensus in your team of what's the lowest that it's likely to be, what's the longest you think it's likely to be, and get some sort of 95%, and then you can look at those things, because otherwise you get into, you know, heated battles and people aren't friends anymore after you have a long debate about what the energy costs are or how long a heat pump is going to last. Whereas if you can just say, these are the ranges and we want to win no matter what those ranges, where it comes out on those ranges, then you can have a rational civil discussion.
Yeah, I was just going to say that, you know, these buildings are owned and operated, as we've all said, you know, 50 plus years. So it would seem that a 50-year time horizon would make more sense to look at something like this. And then, as Mark's suggesting, you do your sensitivity analysis. You lower your high end and then see where you shake out. But the buildings, you know, this is a public building. It's going to be on for a long time.
Kate's gonna go if there's any last questions for her.
Any other questions in the room? I have a couple of others if there's.
I have more that you can.
Burning questions.
Yeah.
I'm just saying, no reason to stop. Thank you.
Thank you for joining us.
Thanks, Kate. Nice to see you.
Bye, Kate. The building looks beautiful.
April 21st. I'm going to sign up.
Thank you.
Yeah, and we have the Nessie invite for that. You know, I'm sure you have it. I know I have it. You can circulate it if people want to sign up.
Yeah.
Great.
Well, I appreciate all the inspiration from some of these speakers. I've been following in the tracks of some of these folks that you're here in touch today. So thank you.
Thank you, Kate.
So some of the conversation has been around setting targets and then ensuring that you're meeting those targets. So what would be a good process for setting an EUI target for a building and then kind of setting yourself up for success up to construction? Get into like during construction and then operations, where I'm going.
Yeah, I mean, it depends on the building type, right? So when we launched our what's called our Path One program for Mass Save, we set a EUI target of 25 for any building type. And we kind of quickly realized that, you know, 25 isn't necessarily the right EUI target for every building type. Libraries use a little bit different energy, office buildings use a little bit different, community centers might be different. And so we spent some time kind of honing in on, you know, what we think are better, more tailored targets for different building types. So if your next project's a library, we've got a, you know, kind of predefined target. We've actually, you know, got a couple of different tiers too. So, you know, 30s, you know, we think the right target for a net zero library, but if you're, you know, in the 35 range, you can still stay in the program and participate. We know 25 is a good target for schools. We've done a lot of them and we think it's very achievable for schools. So that seems to be honed in pretty well. So, but then there's any other building type. So if you're not in one of the, you know, 5 sectors where we've kind of already, you know, nailed down what a good target or target range is, we have a way that we can bring in a consultant like Chris, like other consultants to kind of figure out, okay, based on this building type and the usage and the hours of operation, what's a good stretch EUI target for this? And so we can help you come up with that. And we do that in different ways. We'll look at, you know, we'll look at the building by end use and, you know, we'll figure out, you know, how much is driven by hours of operation and occupancy versus other things. So we have methodologies we can deploy for that. So we'll help set those EUI targets.
There's one really great tool that is accessible to anybody that can use for this. There's something called Energy Star Target Finder. It's part of the Portfolio Manager program. It's free, run by the federal government. What they've actually done is they do a survey of buildings across the United States. They've got thousands of buildings in their database, all different types, and then they've set up algorithms to adjust based on location and type of building and use things like that. And so you can put in the type of building you're building, your zip code, and it'll tell you what an average building would consume. And then you can put different targets in there and come up with different EUIs for that. And that can give you a range of targets. And then you look at that in context with things like the Architecture 2030 challenge that set a goal. In this case, we want to be 80% better than average in 2023, which is a tough one to get to. That's a pretty low target sometimes without renewables. But there's information there. We look at other projects that we've done and also other publicly available databases. One that's been very handy to us is actually the BERDO data that the city of Boston has. They have every building, public or private, over a certain size. It's available online. There's a spreadsheet of all of it. So just as an example, we're doing a branch public library in Skaneateles, New York, right now. And we actually looked at the BERDO data and found all the branch libraries in Boston, and we're able to come up with an average EUI for those as one database point of comparison with a branch library in similar climate zone, different part of a different state. So there's information out there, but the target finder is a really simple way to do it.
And so you could use that for like building retrofits or upgrades as well? Or?
Yeah, and you can actually use that as well. If you have an existing building and you know how much energy it consumes, you can determine whether that building would be eligible for Energy Star certification and how it ranks compared to other buildings. So they'll give you a score on a percentile between 0 and 100. 100 would be the best building, 50 would be average, and you can actually put your data in on an existing building and see how you do it, whether it's good or bad. We use that very often for existing buildings when we're looking at can we improve this building? The first things we'll do is we'll benchmark against other buildings to see how far off is it. Is it a good building already, or is it terrible and there's a lot of low-hanging fruit? That's a way to figure that out. It's a really great tool. They almost shut it down during the preceding presidential administration, but it's there, it's working, it's robust, it's great.
Kim, you mentioned the third-party energy analysis a couple of times, and it sounds like, Chris, that's something that you potentially do. Can you talk a little bit more about how that works in the framework of a project, where that would come in, what's the funding, what's the level of detail, like that kind of thing?
Yeah, so when I'm talking about this program, I'm talking about brand new buildings or complete gut renovations of buildings. So this platform applies to those types of buildings. And so kind of the process is, Cities in Town can engage us anytime. You can engage us all the way before you even select a design team, and we'll help with language for the RFP and all that sort of thing. We can help with the EUI targeting even that early. But a lot of times, cities and towns will call us in feasibility or conceptual design. That's a really optimal time to bring us in. And what we would do is first, kind of explain, like, this is what we do, these are the services that we provide, kind of get people comfortable. If you're signing on with us, you're signing on to set an EUI target, and you're signing on to really commit to actually achieving that target post occupancy. So once everyone's kind of comfortable, then we say, okay, well, the next step is, there's this non-binding memorandum of understanding that you need to sign, kind of lays out how we work with the town, what we provide, what the town needs committing to in terms of doing iterative energy modeling. And then we'll bring in a third-party firm to do net zero kind of support. So it's road mapping services. And that's usually done really in feasibility or conceptual design is the best time to do that. So that's where we can hire them to do the load reduction analysis I was talking about, to really think about trading off, what might you do with your roof, and what kind of infiltration targets might you set, and what might you do with your windows, and trading that off against cost, and really figuring out how to optimize all of that. So we can do that. Then even before this final schematic set is developed and sent to the MSBA and the town votes on it, is when we really do most of that work. So we'll pay for 50% of that scope, up to $10,000. So we do have a cost share for the town as part of that, but it's a lot of times the team already has, the architect or the engineer is already doing some of this, but they needed a little supplement. And so we'll bring in that third-party service to do that supplemental work, again, that will cost share 50% up to $10,000.
Yeah, I would highlight that, especially for a school. If it's MSBA, it's going to be required to meet either LEED or CHIPS. And it's probably also going to need some energy simulation work for code compliance, especially under the new code. And so that is already in that designer scope. If we look at Acton as the example, GTD, the people who did that life cycle costing, they are the design mechanical engineers for that system. And so they did that energy modeling work and that life cycle costing as part of their traditional scope of services. And you had folks come in and do additional net zero help, and that's the scope here. So it's not, you know, there's a lot of that work that's already in the standard design process that there's a little bit of add-on to get you to the right place.
Yeah, and our goal is not to, you know, like redo anything anyone's already doing. So if someone's already doing the life cycle cost analysis, for example, that's great. We don't need to redo it, but you know, maybe having a third-party set of eyes look it over and look at things like, you know, what were some of the assumptions that were made? You know, is there another way to think about this, or you know, do we have the incentives right in there? You know, so those are kind of we always want to be supplementing what the project's already doing, not like redoing.
But with like a level of technical detail that somebody who's not used to doing this kind of thing could really, you know. Right,
and sometimes, you know, we've had a few projects where it's been extremely valuable to bring that load reduction analysis early on. And we've been helpful in getting the team to kind of nail down like a couple different options. So if they had maybe even as early as looking at different site options. So and we can't look at 15 different building layouts and on 3 different sites, but once you hone it down to maybe 3 different options, maybe a couple different building layouts on 1 or 2 different sites, we can help even look at it that early too and say, okay, well, if you pick this layout, it's actually going to give you a half to 1 EUI benefit here. You know, with this orientation versus this other orientation on a different site. So we can do all of that work that maybe the team wasn't originally planning on.
Yeah, and that's something that we talked about at the sustainability committee meeting earlier this week, not for a new building or anything, but for our existing building stock. I know Justin Byrne's done a ton of efficiency work, and specifically like under the green communities umbrella, we've already done a lot of what we can possibly do for a building. So what I understand is the next step would be to look at that net zero planning, even just from a conceptual point of view, to see what kind of comes next.
Yeah, so again, these services that I'm talking about are for new buildings for complete gut renovations, so major capital projects. However, in other areas of Mass Save, we do provide support for decarbonization of existing buildings. So Justin's nodding. So we can come in and talk to you about if you wanted to decarbonize this building, for example, as an existing building, you know, we can come in and talk about what that might mean and help you analyze that, as well as doing all the energy efficiency work that we've always done traditionally.
Yeah, we work with DOER, and they're working on a significant amount of decarbonization programs that haven't really been implemented. So when it comes to that, the incentives are somewhat lacking, and it takes a lot more local funding up front to get there. And in Maine, we traditionally have trouble obtaining that upfront local cost to help move those projects along. But we always explore every single aspect of decarbonization and incentive programs that we can take.
You guys have done a really great job.
So in answer to a question you asked maybe 5 minutes ago about how do you set your EUI targets, in Lexington we set our targets by saying we want to be, at the time we were thinking about the stretch code, and we said we want to be stretchier than the stretch code. And so we said we want to be 30% better than the underlying code. But the interesting thing, and I'd be interested in Chris's perspective on this, is the code has evolved over time. And Lexington just recently at our town meeting adopted the specialized energy code. And as we have been in this meeting right now, Boston, while we have been talking, just adopted the specialized energy code. So I would be interested in, I was having some discussion with some of the folks here in Lexington about whether the standards we set 4 years ago are actually going to be more stringent than the specialized code. I'd be interested in Chris's perspective, but one of the things you could be thinking about, instead of having a big debate about, you know, what EUIs should you set for your buildings, maybe your debate is, should we be adopting the specialized code?
So it sounds like I'm supposed to respond to that. My understanding of the specialized code and what I've seen is it doesn't really raise the bar in terms of energy compared to the stretch code. But what it does is it says use electricity. It really pushes you to electrify, to eliminate fossil fuels. You either have to be all electric for your heating and your domestic hot water, or have a plan in place, and it's not sort of a hand waving, yeah, we can do it someday. It's an actual alternate design with all the space and all the electrical connections and everything, to the point where you're going to go that far, you might as well do the whole thing. But the new stretch code, which is part of that, is a significant bump up from where our existing stretch code was, which was already pretty aggressive. So, you know, to the larger point that Mark was saying, 30% better than code is going to be pretty darn hard. Mark, we should look at that for the high school, because you at some point you can't get much lower. The code has kind of captured everything that used to be optional and made it a requirement. And so you know, I think we'll see a big change in the way that buildings are built with the new code, and people are just now kind of getting their head around what's actually in that code.
So then, so if you've designed a building, going to be energy efficient, ready to go. So what do you need to keep an eye on in construction and then in operation, making sure that everything is working the way that you intended, that you're actually achieving those goals that you have set out and worked so hard to set yourself up for?
So the first thing is commissioning. There's a process called building commissioning. And again, if you're doing an MSBA project, for example, they typically are providing a commissioning agent as part of that. And so what we're seeing now is we want commissioning agents, not just looking at the mechanical systems, but also building envelope commissioning, make sure we're getting good quality building envelope, because that's really the key to this whole thing. But you know, the commissioning is about making sure the design intent has been realized, and ideally the commissioning agent is involved during the design so that they can make sure it's going to line up with what people can actually do. And then a key part of that as well is engaging the facilities managers, making sure that people who are going to be operating the buildings have a clear understanding, training is set up, and resources so that when people change, you know, when you have personnel changes, you don't lose that institutional knowledge. And that's a tricky thing to do. And then another big piece that Eversource really pushes is installing enough information gathering, specifically metering, so that we know where the energy is going. Because if we find out that, you know, we said we're giving an EO of 25 and we're actually at 35, it'd be helpful to understand that, oh, gee, it's because the lights are consuming more. It's because the mechanical system is running longer, those sorts of things. Right. But if you don't have that kind of sub-meter data, that's very hard to track down.
I was going to mention exactly that. We put in our policy that you have to sub-meter for any load that's 10% or more of the building. But that was like 4 years ago, and now CTs, current transformers, you can put on your panels. You can put smart panels, and you can monitor everything now pretty cheaply. So, to your point, Jeff, technology is changing rapidly. What was possible 4 years ago is now it may have been difficult 4 years ago is much easier today.
And there's one additional piece I'll just layer on too. Again, with this Path 1 offer that I've been talking about through Mass Save, we do want to really focus on that post-occupancy performance. That's why we've created our incentive structure the way we have. And there's a big chunk that we hold back pending, looking at the actual operational performance. I was going to mention all the commissioning that Chris mentioned, and particularly the focus on envelope commissioning being really important there, and the sub-metering too. We have an additional bonus incentive. It's called our verification incentive. And so what we suggest is sort of it could be an add-on to the commissioning agent scope. It could be an add-on to the MEP engineer scope, but that someone is actually looking during the post-occupancy period at multiple points, 2 months, 6 months, 10 months, 1 year point in time, actually pulling equipment trends during that period of time and actually pulling energy use data during that time to check back and see, are the control state sequences that we put in this design, are they actually functioning properly? If not, why not? And let's make sure we're looking at that while the contractor's still on board, ideally, up to the end of the warranty period. So as much as possible during that period, but then also looking at that actual energy use data and comparing it back to the model, saying, okay, is this what we expected to use in these shoulder months or whatever season we're in? And if not, well, why not? And then take corrective action. So, I think that we really, I think we're going to learn a lot as these projects that we're working on are actually going into occupancy now. And we're going to hopefully generate those feedback loops back to the designers and modelers and share with other communities the lessons learned over time.
That's really valuable. There hasn't been a good feedback loop for a lot of this. You know, us engineers find you didn't call and complain, you didn't sue us, so it must have done all right. But it turns out some of our buildings are not performing quite as well as we hoped.
Well, energy management is kind of like a new, especially in the municipal space, is really new, I think. I know there's a few towns that have it, but most of us don't.
Having somebody like Kate is a prime example of the difference that a person can make.
Right. And just, this is just from a residential perspective, but when I put my heat pumps in, I put in these sensors. I now have, Kim, you're gonna think this is crazy. I think it's kind of crazy. I have 1 second interval data on all my 1 second interval data. It cost me $125, and that's it, right? So it's going to cost municipal at least what, 100 times more than that, Chris, but it's still kind of cheap in the overall process of the building.
Right. Yeah, having better data there. We've seen that pay off already in some projects. We had one, just as an example of doing things wrong. The energy data was different, and one of the things we found was that they had some extra cash after bidding, and unbeknownst to us, had accepted an alternate to put in snow melt for part of the facility, which is fine. Snow melt, you can argue, versus the snow blower might be a better thing. But it turns out that the snow melt was on in September. So nobody needs to be heating the sidewalk in September. And having some metering data, we were able to figure that out. The facilities manager said, no, I turned that off. There's the switch. And somebody else said, no, that's not the switch, that controls something else.
And that happened in Aspen too. They were heating the sidewalk all summer.
Yeah, so you know, maybe don't do snow melt, but having metering means that you can track down when something like that is happening and fix it, along with conditioning and all these other pieces. And there's still going to be things that don't work right. It's been great.
I've enjoyed this. I do need to go to my next meeting. And so if anybody has any questions, feel free to reach out to me. I'm sure Kate or somebody can get you my information if you'd like questions to me to follow up.
Thank you, Mark.
Do any of you have experience with funding mechanisms through like the green bank or anything like that? Or is everything that you work on paid through municipal bonds?
Well, we do a lot of non-public projects as well. You know, so there's a variety of funding. Definitely people, especially in the for-profit sector, have been taking advantage of some of the tax credits for years. I'm not aware of fundings like a green bank, other than we've seen some large institutions like Harvard being a prime example, where they have internal accounting mechanisms basically that allow a project to borrow money from themselves to do things with a lower life cycle cost.
Sometimes they set up revolving funds.
Right.
So that, I mean, we've seen that with a lot of our university partners, where we as Mass Save might have done a lot of work with them over time on their existing buildings. So our incentives will go into a revolving fund, which they pull from for other projects. So that's a mechanism we use.
Yeah, but as far as other third-party funding sources.
Yeah, I don't think we have a green bank in Massachusetts.
Yeah, I don't think there is one. There's talk of moving in that direction, but there's also some other, I don't know, through USGBC, there's talk.
Well, there's the PACE funding, which I know very little about. And the other thing that's been around for a long time is performance contracting. Yeah. And so especially for existing buildings, the performance contracting is kind of the PPA version of energy efficiency. Somebody comes in and does work for you and you don't pay for it, but they get the savings. Ideally, there should be somebody who could come in and say, we'll give you the extra cash you need up front to do your geothermal, and we'll take the savings as a way to fund that.
Yeah, we were talking about that. I mean,
that doesn't exist.
It doesn't exist yet, but it's really interesting to think about that, because it sounds like Maynard, I mean, maybe you can't count on that IRA tax credit, or maybe you're just worried about it. So just having an entity that's able to come in and kind of bridge that, that maybe that's something we need to think about at the policy level.
That's something we see in a lot of municipalities. Getting something through town meeting is a tricky process, right? And so you got to be able to bring a lot of people together. And make sure. And so things are kind of up in the air. People aren't going to vote for it.
Yeah.
I also need to jump out, but I just wanted to thank everybody in the room and for organizing this. So very appreciative, very informative. So thank you, everybody. Hope you have a good afternoon.
You're welcome.
Thank you.
Yeah, thank you. I know we're on your good graces now, coming up on the limit, but I think there's a big picture question that we should be asking if we're thinking about municipal buildings, net zero. Given the reason we're trying to do this, how can we be assured to build our new net zero building? How can we be assured that it has a net carbon benefit?
Would be assured it's a net carbon benefit.
Relative.
Because we have a whole lot of upfront carbon, steel and concrete.
So this is a great question. So we can look at embodied carbon. There's a process called life cycle assessment. We're just working with the town of city of Newton. They don't like when I call them the town. City of Newton. They're building a new senior center, and it's on the site of their existing senior center. And there was a question that was asked by the community: shouldn't we be renovating this building instead, given the amount of carbon that would be saved? And so we compared the embodied carbon of the new building against renovating the existing building. And then we also compared the energy consumption of a new building with an EUI around 25 against an existing building modified, but not having an EUI that low. And what we found in that particular case, and it was unique to that case, is that the carbon payback was around 7 years. So for 7 years, there would be an advantage to renovating that existing building, but beyond that, the carbon impact of the new building was going to be lower. So there's a question of how quick we need to do things, and the answer is really quick. So maybe even 7 years is too long, but for Newton, that was enough to say yes, we do want to build a new building. There are a lot of strategies that we can use to reduce the embodied carbon in the building. We're seeing a lot of move towards mass timber construction at much bigger scale than you could ever imagine. There are also standards coming in line on low carbon concrete as a simple example. And so, a lot of different ways to look at that. Almost all of the embodied carbon in a building is the structure and the enclosure, because those are just the pieces that have the most stuff in them and the most carbon, and especially concrete and steel are very high carbon. So we do want to care about that, because the building that's going to last 100 years, the operational carbon is spread out over 100 years. At the end of 100 years, it's going to be pretty high, but that initial carbon is right now. And if we listen to the scientists, they tell us we've got a few years to kind of make it through this eye of a needle. So it's a hard question to answer. Where is that trade-off? It often becomes part of it is what do you need the building for in the first place? And if the building isn't going to serve those needs, very well, then you need to think about that. That became one of the key concerns with the project in Newton. Is the existing senior center had been built originally as a library. It wasn't well suited to what they wanted to do, so it was going to take a lot of changes to it to make it work the way they wanted it, which is why it had a short payback. But conceivably, if your choice here in town is renovating a school or building a new one, the payback might be more like 15 or 20 or 25 years with the carbon, in which case you may want to think about kind of it. But there's lots of tools available to do that analysis, and a real growing knowledge base. The Boston Society of Architects we talked about has something called the Carbon Leadership Forum. CLF, not to be confused with the Conservation Law Foundation, who have been doing a lot of work with the architecture community in Boston, looking at embodied carbon and ways to reduce. So it's definitely a growing knowledge base.
Yeah. It's a national conference. I was just on a
they've national. There's a local version of it for the Boston Society of Architects.
Big push on the West Coast for embodied carbon.
They're actually getting some free online tools that can help you do that very easily. I'm happy to pass on those links if somebody's interested. All right.
Thank you, everyone, so much.
Yeah.
Thank you for joining us. And thank you to everyone that's been able to join us in person and online as well. We've got this recorded, so we'll be able to share it out later.